Welcome back to Pre-Algebra. Today we're going to be doing Chapter 2.4, Variables and Equations. So this, remember I told you in the beginning that there'd be certain things that are really important and other things that are not really important, but they're interesting. And that I'd tell you which is which, so when it was really important you'd pay close attention and make sure that you understand it. What we're doing today is, I'd say, the most important. Of everything you learn in algebra, it's the most important. And we're going to not just talk about it today, but for the next 4 videos, and also really from now on. This is what we're going to do. And it won't surprise you that this is solving for x. Okay? So let's talk about what is a variable. Well, when you started off in math, that x meant times. It doesn't mean times anymore. Now a dot or parentheses, there are other things that mean times now. This means a variable, and where the name variable comes from is it varies what it could be. That x could be a 3, it could be a -4, it could be a billion. X is an unknown number, and we're going to figure out what it is. Sometimes we use y or p or n. I like x because remember I told you I'm dyslexic, and x, if you flip it upside down or turn it over, it's the same thing. So I really like x. Alright, so here, what does this mean? It means some number, we don't know what it is, plus 6 equals 9. 12 minus some number equals 15. -4 times p, remember a number sitting next to a letter means multiply, equals 32. N, some number n divided by 2 equals 9. And so that's just what those things mean. Now they always start with this problem, and you do this problem for this lesson and then you never do it again because this is not the way to do it. I'll explain what you mean. So here's the problem. Some number minus 5 equals 2. Is it 9 or is it 7? Well, one way to find out is to substitute 9 in for 5 and see if it makes a true statement. So we sing the song, substitute. And now we're going to put 9 right where x was, right underneath. So 9 minus 5, does that equal 2? Ooh, the suspense. 9 minus 5 is 4. 4 does not equal 2. The answer is not 9. Well, let's see if it's 7. Is x equal to 7? Let's find out. We're going to sing substitute and put it in. And is that equal to 2? Oh, the suspense. 7 minus 5 is 2. Yay! The answer is 7. Yes. Now this is not a good way to do this problem because you'd have to go through every number in the universe until you found the answer. So no good. Luckily, there's a better way, and this is how you do it. What you're going to do is you're going to ask yourself a series of questions and answer them. The first question you ask, at this point, later on we'll learn another question, but right now, the first question we're going to ask is, why is x not alone? And well, let me back up a second. To be able to solve for x, there has to be an equal sign in the equation. So step 1, check, is there an equal sign? Yes, check. Number 2, ask yourself, why is x not alone? And by alone, I mean on its side of the equals. What is here on this side of the equals with x? It's a plus 3. Then you do the opposite. The opposite of plus 3 is minus 3. And you're allowed to do that as long as what you do to one side of the equals, you do to the other. In fact, in math, you're allowed to do anything you want as long as you do it to both sides of the equals. We're not going to write that this equals 0 because then the x wouldn't be alone anymore. We're going to mark it out. We bring down what we didn't mess with, the x and the equal sign, and then we do the math. 11 minus 3 is 8. So now we know what that mystery x equaled. It was 8. You just solved your first algebra equation. Yay! I'm so proud of you. Let's do another one. Why is m not alone? This one's tricky. It's got a 16 here. Is that 16 positive or negative? It's positive. You look in front. So what's the opposite of this positive plus 16? Minus 16. What you do to one side, you do to the other. These mark out. You bring down what you didn't mess with, including that negative sign right there. 9 minus 16 is negative 7. Now, why is M not alone? It's got a negative sign. That negative sign means an understood negative 1. It's being multiplied by a negative 1. What's the opposite of multiplying by a negative 1, do you think? It's divide by a negative 1, and that's how we write it. What you do to one side, you do to the other. These mark out. 2 negatives make a positive. M, we need a little room here, equals 7. Now, these are actually hard ones that I'm showing you. If they don't make sense, don't panic. They just try to teach you some weird way first, and I'm like, let's not bother with that. Let's take the training wheels off and go ahead and learn how to solve an equation. So I'm teaching this a little early to you in the book, so the examples they give you are a little bit hard, but I think you're going to do okay. The more you see it, it's going to click, 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 and you're going to get it. All right, let's do this one. Why is x not alone? It's being multiplied by a 5. What's the opposite of multiplied by 5? Divide by a 5. What we do to one side, we do to the other. These cancel out. 20 divided by 5 is 4. And it doesn't matter which side the x is on. Another thing, when we did that subtracting 11 minus 3, we don't do it like this, 11 minus 3 with the equals bar, because that bar, we're not going to use that for equals anymore. We're going to use a bar to be the fraction bar, which means divide. Okay, here's one more. Why is y not alone? It's being divided by a 6. What's the opposite of dividing by a 6? Multiplying by a 6. What you do to one side, you do to the other. These cancel out. Y equals negative 6 times 3 is negative 18. Let's do that one. It's fancy. Why is x not alone? It has a plus 500. What's the opposite of plus 500? Minus 500. What I do to one side, I do to the other. Those cancel out. I bring down what I didn't mess with, the x and the equal sign. 2,000 minus 500 is 1,500. Woo, that was a big one. It was fun. So it doesn't matter if the numbers are big, you can still do it. Now, when I taught public school, to honors 11th and 12th graders, they could not do this. And I don't really totally think it was their fault. I think it was the way they had been taught. But you're going to be able to do it. Something that honors 11th and 12th graders couldn't do. So, all right, they probably could do it in math class. They couldn't pivot and do it in science class. They would get to science and they were like, I don't know how to do that. Especially if x was in the denominator. Oh, we don't have one. That would just blow their minds. All right, we'll do it again next video. You're going to get it, I promise. Math is fun and great.